Our topic for today is antibiotic resistance, which is the climate crisis of the medical world, as quoted by Dag Beryl. The time may come when penicillin can be bought by anyone in the shops. Then there is the danger that the ignorant man may easily underdose himself and, by exposing his microbes to non lethal quantities of the drug, make them resistant. This is a famous saying by Sir Alexander Fleming, which we'll be able to understand as we look into the later slides. What are antibiotics? These are the substances that may inhibit or kill any bacterium. Some are specialized while some have a wide range of attack. These are also used in patients before surgery to prevent unwanted infections. Now, what do we understand by antibiotic resistance? Simply put, it is the bacterial ability to resist an antibiotic. These bacteria are often called superbugs. It is majorly concerned with overuse of antibiotics, that is, drug resistance. It is not the host but the bacteria that slowly becomes resistant, and they may attack humans and animals. With decrease in antibiotic effectiveness, infections like pneumonia, tuberculosis, blood poisoning are becoming harder or even impossible to treat. Procedures like organ transplantations, chemotherapy, and surgeries have become much more dangerous. The accidental discovery. Alexander Fleming discovered penicillin in 1928. When he had returned from a 2 week vacation, he found that a mole had formed on a Staphylococcus culture plate, preventing its growth. The substance was produced by Penicillium notatum. His discovery was further researched and finalized by Howard Florey and Ernst Chain. Penicillin was termed as the miracle drug of World War II. Previously, there were no medicines for treating the smallest infections, therefore decreasing soldier count rapidly. In 1940, the first person to be treated with penicillin was a constable named Albert Alexander. The popular legend is that he acquired sepsis after pricking himself while pruning roses in the police house garden. He, however, could not survive as enough drug wasn't purified at the time. The production became the top priority in the later years, especially in 1943 for the wounded soldiers in the battlefield. In the same year, penicillin stocks were supplied to Allied troops in Europe, and on June 6, 1944, 73,000 US troops landed on Normandy, boosted by the miracle drug. Esther and Joshua Lederberg in 1952 performed their famous replicating plate experiment, which concludes that pre-existing gene mutation is the basis of adaptation. In short, bacterial colonies were stamped on penicillin-containing plate. Colonies X and Y survived even though they had never encountered the drug before. So they did not evolve due to the exposure but were already penicillin resistant. We can conclude that mutations are pre-adaptive and random, and that evolution is not directed but based on chance events. This is a timeline that depicts different germs showing resistance over time. Staphylococcus aureus was found resistant to penicillin in 1942, Streptococcus pneumoniae in 1967, and Neisseria gonorrhea in 1976. In 1960, Staphylococcus aureus showed resistance to another antibiotic called methicillin the same year the drug was actually put in use. This has been the trend over time: development of an antibiotic and then appearance of its superbug. Now we look into a highly important good bacteria, Lactobacillus, which is a group of rod-shaped, gram-positive, non-spore-forming bacteria. These are found in the gastrointestinal tracts, mouth, and the vagina. Their characteristic ability is lactic acid production, which is actually a byproduct of glucose metabolism, therefore commercially making it very valuable as an important probiotic. Genes responsible for resistance against streptomycin have been found in Lactobacillus plantarum, and in some strains, a resistance against tetracycline, gentamicin, ciprofloxacin, and vancomycin have also been found by researchers in Egypt and Turkey.